Okay, welcome to Paper 1, Topic 2, Electricity. In this topic, we learn all about electricity, and we're going to start off with a recap of Year 8. So, in Year 8, we start our very first lesson by giving you a battery, like so, with a plus end, that bit there, and a minus end. And we give you a light bulb. So the light bulb looks something like that, a little bit at the bottom. And the aim of the game is to get the light bulb to light. So eventually people do things like take a keychain and a key, and they go for metal objects, and then they get their key, something like that. Can't draw a key, but hey, you get the idea. And they touch it on there, and then with this bit they'll use something like a protractor, something like that, sharp protractor, and then they'll touch the end there, and they'll complete the circuit. So the idea is that the energy from the cell is transferred over to the bulb, and the current then has to return to be reloaded up. And so we learned that quite early on, and keywords that we use most definitely are completed circuits. We complete our circuit. We use conductors. So instinctively people go for metals, paper clips, scissors, that kind of stuff. They don't go for the rubber and the pencil sharpener if it's made of plastic. And then we learned that we can draw those as proper science diagrams. So if I shrink this one down, we can turn this little picture into a proper science diagram. And when we're drawing them, we always use a ruler and we always use a pencil so that we can change it if we make a mistake. So the symbol for a cell, which is one part of a battery, is a big one and a little one with a little plus. Big is always plus, little is always minus. Okay, wires are always drawn at 90 degrees, either going sideways or up. Doesn't matter what it's made of, we always just draw it like this. Bulbs are drawn as circles with a cross through them, and then we complete the circuit like so. There we go. Okay, so we have drawn a complete series, and we'll talk more about that in the next lesson, circuit. Okay, and the key word here absolutely is the idea of complete. A complete circuit. So get that in all the time. Complete, complete, complete. Right, we're going to be plugging in loads of different components and learning about them. So the aim of the rest of this lesson is to recognise the symbols and the function of some of these components. So if you could copy that lesson objective in, and we're going to go quickly through all the things we're going to look at. So we have a table that we're going to draw. At the top we have name, symbol that we're going to draw in the circuit, and what it actually does, what its function is. So the first one we'll draw is an ammeter, like that, and its function is to measure current. Nice and simple. Right, the next one is a voltmeter, and funnily enough measures voltage. We'll talk more about what each of those really means later on. For now, we'll just learn the symbols. Next, we'll do a resistor, which is a rectangle, like so, and it slows the current. I'll put slows the flow of current. Okay, now we have a variable resistor. Remember, if I ever go too fast, press pause, rewind. Okay, a variable resistor is a resistor with an arrow through it, and it changes the flow of current. So if you've got a dimmer switch in your house for the lights, this is a variable resistor. It goes up and down, allowing the current to go fast or slow. Next, an LDR, which stands for a light dependent resistor. Okay, and in this case, again, we draw a resistor, This time though, we draw a circle around it, and we draw it being hit by light. And as the name gives the clue, it's a resistor that changes resistance with light. So it changes resistance with light. Okay, so you've got those in like security lights. You've got them in your phone. They're hidden all over the place. Next, thermistor. So think about it. Istor, well, that stands for resistor. Therm, so what does this one change with? And if you're thinking to yourself, temperature, heat, you're correct. Thermal. Now this one is a resistor, but it plays golf. Boop. You draw it through like that. Imagine a putter. So this one changes resistance with temperature. Okay, so these are in your kettle, these are in your heating systems, they're in your PC, they're in your phone. If you've ever overheated your computer or your phone started glitching out because it got too hot, it's the thermistor that's responsible for kind of keeping it safe. The last one is a funny old little one. It's a triangle like that, which looks like an arrow. And a diode only allows the current to flow one way. So current can flow that way, tick. But if it tries to flow that way, it hits this wall and it can't get through. So we talk about that more in a few lessons time. For now, we'll just say only allows current to flow in one direction. Now, there's a couple on here that I didn't pre-write the name of, but they're really kind of obvious. We'll give them a go. And that's battery and cells, because people get a bit confused. So, a cell is an individual chemical little ball of chemicals. Okay, so a cell, and a cell looks like this. It's one big one plus and one small one minus. Okay, and it's a unit of two chemicals that create electrical energy. Okay, so one of them is called a cell. Now, a bit like if you have lots of chickens, you have a battery of chickens, or if you have lots of guns, you have a battery of guns. Then likewise, if you have a battery of cells, you have more than one cell. So when we use the word battery, what we're actually meaning is inside of it is usually more than one cell. So a battery would be 1, 2. So something like that. You don't need to draw the plus and the minuses. So 2 or more cells is a battery. 2 or more cells is a battery. So technically the real word is a battery of cells. And if you open up certain big batteries, inside them are smaller cells all packed together to make the voltage. Okay, I think that's it for this lesson. Take care. Bye-bye.